Okay, hi guys. Here are your notes on geometric mean. Geometric mean is a way to set up a proportion between three right similar triangles to solve for a missing side. So our first theorem, if we have a right triangle and we draw an altitude from the right angle to the hypotenuse, the two triangles formed are similar to the original and to each other. Okay, so here's all three of those triangles split up. We have the large one, the small one, and the medium one. And we can write proportions comparing the side lengths of these triangles. Okay, we have the short leg to the long leg. Okay, so that would be B over A in the big triangle. That would be X over H in the small triangle. And that would be H over Y in the medium triangle. If we do hypotenuse over short leg, that would be C over B in the big triangle, B over X in the middle triangle, and A over H in the medium triangle. And finally, we can do hypotenuse over long leg, so we would get C over A, B over H, and A over Y. Now make a note when we have geometric mean, make a note of the common diagonals we have here. The means are the same, okay, in those proportions. Remember that as we move forward. Okay, so the first theorem you have for geometric mean, okay, is the geometric mean altitude theorem. An altitude drawn from the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of the altitude is the geometric mean between the lengths of these two segments. Okay, it's a really long theorem. You do not have to memorize it. Instead, we're going to remember the acronym PAP. Okay, the letters in PAP stand for P, we'll call it P1 for part, A for altitude, and then P2 is the other part. Now the parts are the two segments your hypotenuse is split into. One is P1, the other is P2. Doesn't matter which one you call which. And then your altitude is your altitude. So knowing those pieces, that's how you can set up this proportion. So if we were to substitute the values from this triangle into our proportion, part 1, we would get X. My altitude is H. And part 2 is Y. Okay, and you can see the means in that proportion are equivalent. All right, so let's try an example. Solve for the missing parts. So we know we have a right triangle. Always label your parts before you get started. So we have our altitude. I'm going to make 5 part 1 and 20 part 2. Okay, and we can set up PAP. And what I want you guys to do is write out the formula for the proportion until you get used to setting it up. Okay, so part 1 is 5. My altitude is X. And my part 2 is 20. Okay, remember when you multiply x times x is x squared. It is not 2x. And we get 100. Take the square root of both sides. And x is technically plus or minus, not 100, plus or minus 10. But we're not going to keep the negative answer because we can't have a negative side length. So we're only going to keep the positive. So x is 10. All right, let's try another one. Okay, so this time one of the parts is missing. My altitude is 12. I'm going to make P1 9, and part 2 is going to be x. So I'm going to, using my PAP equation, okay, 9 over 12 equals 12 over x. 9x equals 144. All right, and if we divide this, x goes in, 9x goes into 144, 9 goes into 14 once, we have 5 left over, 9 goes into 54 6 times, so x is 16. Now, if you think about how can you check your answers, you can plug x back into your proportion, and if your ratios simplify to equivalent ratios, then you're good to go. All right, our next theorem is the geometric leg theorem, which says the altitude drawn to the hypotenuse of a right triangle separates it into two segments. The length of a leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Really long theorem, and again, you do not have to memorize it, so we're just going to stick with the acronym HELP, where H stands for hypotenuse, L stands for leg, and P stands for a part of the hypotenuse. Okay, now there's two different ways we can set up HELP. Okay, if we look at C would be our hypotenuse, and we are going to have part 1 and part 2 because the hypotenuse is going to be split into two segments by the altitude, and then we need to label the corresponding legs. If X is P1, leg 1 has to be B, and leg 2 has to be A. So remember, leg 1 and part 1 have to be next to each other, and leg 2 and part 2 have to be next to each other. You can make them whatever you want as long as they are next to each other. Okay, so our two proportions, we have HELP with leg 1 and part 1, and we have HELP with leg 2 and part 2. Okay. And if we want to plug in some values, I'm going to use leg 1 and part 1. So my altitude, C, with leg 1, B, and part 1, X. And notice your legs are the geometric mean of your proportion. Now, when you set up your proportion, and this is for all of these, if your geometric means are not the same, then you've substituted in something incorrectly. So make sure you check that before you start. Okay, let's try another example. Solve for the missing parts. Okay, so if I look at this triangle, I'm going to use HELP, and you can see they have not labeled the altitude. So we're going to use our hypotenuse and our legs and our parts. So I'm going to make part 1 5, part 2 20. That means X is leg 2 and Y is leg 1. Okay, now they did not give us the hypotenuse, but we can easily figure it out by adding the two parts together. And our hypotenuse is 25, and we'll need that for our proportion. Okay, I'm going to solve for Y first because that's my leg 1. So I'm going to use HELP with leg 1 and part 1. So 25 over Y equals Y over 5. You get Y squared equals 125. Okay, and if we do our square root, of 125, we will get approximately 11.2. And we're just going to round to one decimal point. All right, and now if I set up for solving for X, I'm going to use hypotenuse over leg 2 equals leg 2 over part 2. So 25 over X equals X over 20. Okay, and X is going to be the square root of 500. And we're going to only keep the positive answer, and that's going to be about 22.4. All right, and that is, I think, oh, we have one more example. Okay, now this one we have three parts to solve for. We have X, Y, and Z. Okay, Z should be really easy to solve for because we have both parts of our hypotenuse, so 16 plus 9 is 25, so I know my answer for z, and that's also going to be my hypotenuse. So what I'm going to do first is label everything. So if 16 is part 1, that means that x is leg 1, and if 9 is part 2, that means that y is leg 2, and 25 is my h. Okay, if I want to solve for x first, using help with leg 1 and part 1, 25 over x equals x over 16. Okay, we get x squared equals 400, and then x should be plus or minus 20, and again, we're only going to keep positive 20 because we're looking at a length of a side of a triangle. Okay, and over here, I'm going to solve for y using help with leg 2 and part 2. 25 over y equals y over 9. Y squared equals 225. And we get plus or minus 15, and we are only going to keep the positive answer. And again, you can check all of your problems by plugging in your answers into your proportion, and if you get the same ratio on both sides of the equation, you're good to go. All right, try your practice problems in your textbook, and we will go over any questions you guys have next class. Have a great weekend, guys.